I'm going to walk you through how to read the standard normal distribution table. And if you notice, it says cumulative standard normal distribution. Cumulative means up to and including. It relates to probability and or area. So it ends up that the area is up to and including, or always to the left of the value that we're looking up. And Z is the value that we're looking up. And Z will be on the horizontal axis, or it could be the area under the shaded region is all the values less than this little value of Z. Or if you're to the right of 0, it's the values again to the left of the value Z. So this is called the Z distribution. You notice how the use of Z's, and this little z is one particular value of all the possible Z values that are going to happen. Notice that in the center is 0. It's the same curve, just with the Z in a different spot. All the values to the left of 0 are negative, just like a number line, and all the values to the right of the right of 0 are positive. Notice how the shaded area again is to the left, or to the left. It's cumulative. So the areas are cumulative. So as the values of Z increase, like this, as the values of Z increase, the area to the left, or the red region, gets larger and larger. When we're exactly in the middle at 0, then the area to the left is 0.5, because the standard normal distribution is exactly symmetric. The area to the left of 0 is 0.5, and the area to the right of 0 is 0.5. So when I'm looking at a negative Z value, notice how I have less area to the left than I do to the right. And when I'm looking at positive Z values, I have more area to the left and less to the right. So knowing where the value of Z is down here on the axis, you'll be able to tell whether the probability of that occurring, or the area under the curve, will be more than 0.5 or less than 0.5. So the area under the entire curve is 1, or 100%. So let's take a look at some of the values. This table is broken up into two pieces. Z is actually broken up into two pieces. The units place value and the tenths place value is in the first column, and the hundredths place value is in the first row. So if I take a value, I'm just getting a piece of paper, straight edge, anything. If I want to look up the value, let's see, let's just say about here, between 1 and 2, a little bit more than half, let's say 1.63. I just made that up, 1.63, that looks about 1.63. So when I look up on the table, I'm going to be looking up the red region, 1.63. So I look up in the row 1.6, and I go under the 0.3 column, 0.3 column, and I get 0.94, let me say that again, 9484. So if I look up 1.6, I'm going to get the area to the left of 0.9484. Organize yourself this way as you're looking up in the table, and you could utilize this in your work. So let's look up another one. So 94, about 95% is to the left of 0.9, sorry, what was that value? 1.63. About 95% over here, and about 5% down here. Looks about right. Let's look up another number. Let's look up, how would we look up to the right of negative 2. I want to look up negative 2 point, see, I'm on the negative side, 27, negative 2.27. I want to look up to the right of negative 2.27. That's a lot. Let's look at the table and see what we can get. So let's look up negative 2.27, negative 2.2 row, and the 0.07 column. I only get 0.0116. That's the area to the left. The area to the right is going to be 1 minus 0.0116. 1 minus 0.116. And that's 0.9884 when I do that math. What did I do over here? What was I doing? I actually looked up positive 2.27. So if I was to draw a curve, let me draw the normal curve. I know zero's in the middle. Negative 2.27. I wanted to the right of negative 2.27. This area right here was 0.0116, and the area shaded is 0.9884. But due to symmetry, I can take the whole curve, turn it around. Here's 0 in the middle. If I flip it around, this is going to be positive 2.27, and to the left of that, and when I look that up on the table, positive 2.27, I get 0.9884 due to symmetry. And of course, to the right of that is this little piece right here, and that's 0.0116. And if you look, to the left of the number plus to the right of the number will be all 100%. So you can use symmetry to get areas to the right, or always do 1 minus. So just taking a look at what I just did, the area, the region Z greater than negative 2.27 is here. The probability of that occurring is the area under the curve. That's equivalent to the probability that Z is less than positive 2.27 to the left due to symmetry. So I flipped it over, and whether I do 1 minus 0.0116, that will equal the area under the curve to the left of positive 2.27. Either way I look at it, the answer is 0.9884. The safest route to go for areas to the right is always do 1 minus the area to the left.